Hello, in this video I'm going to talk about how to create a very simple C program to display numbers in 7 segments or using the 7-segment format. Let's first see what the problem wants. Basically, we would like to display digits from 0 to 9 using this format. The top row are digits from 0 to 4, and then the bottom row are digits from 5 to 9. Each digit can be represented by a combination of these 7 segments that you see. 3 of them are horizontal, and for the other 4 are vertical. And for each digit, some of them are on, some of them are off. For example, for digit 8, all of them are turned on, but for example, for digit 1, only the 2 right vertical ones are on, and so on and so forth. You can see the way these 7 segments are lightening up, and they want to represent different numbers. As you see, I have labeled them from A to G. A, B, C, D, E, F, G are the labels, and you can say, for example, the horizontal ones are A, G, and D. The vertical ones are F, B, E, and C, right? So you need to create a program that represent any positive integer using this representation. In order to do that, you need to use asterisks, and for horizontal segments like A, you need to have 2 rows of asterisks, and for vertical segments like, let's say, B, you need to use 2 columns of asterisks. The length of each horizontal segment or vertical segment is given by the user of the program. I will talk about that, but this is basically what this program needs to do in summary. But let's begin the details. The program starts by displaying the following message. As you see, this is the message that the program prints out. It says this is a 7-segment display. Press enter after providing any input or any number in keyboard. You got to remember, whenever you type something like a number to interact with the program, you need to press enter. That's how it's supposed to work. And then it says it asks you for the first input, which is the length of horizontal segments. It says, please enter the length of horizontal segments. When I say length of horizontal segments, I mean how many asterisks do we need to have for one horizontal segment. In this case, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 horizontal, there are 16 asterisks for the horizontal segments. And then we have a different length for the vertical ones. After the user enters the length of horizontal segments using keyboard, then your program will check the enter length to make sure it's correct. If the length is less than 3 or is greater than 40, then the program must print a message stating that the length is not acceptable, and the user must try entering the length again. When the user enters an acceptable length for the horizontal segment, then the program moves to the next command or the next message. It prints out the following message. It says, now enter the length of vertical segments. For this example, this is an example of digit 8. The length of the vertical segments would be 1 asterisk, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So there are 12 asterisks for every vertical segment, or like 2 columns, each one with like height equal to 12 asterisks. Basically, after this message, the user is supposed to enter the length of vertical segment using keyboard. Of course, after every input, the user has to press new line. Let's say the user enters the keys, for example, 1, 5, enter. That means the user enters 15. Your program will check the entered length. If the length is less than 3 or greater than 40, similar to the previous input, the program must print a message stating that the length is not acceptable and the user must try again. If the length of vertical segment is greater than twice the length of horizontal segment or less than half of the length of horizontal segment, then the program must again print the same message saying that it's not acceptable, you need to try again. So there are a little bit more restrictions on the vertical segment's length, because the program already knows what's the horizontal length is, so it compares the vertical with horizontal. It shouldn't be a lot bigger or a lot smaller. It can be anywhere from half of the horizontal segment length to twice the horizontal segment length. If it's less than that, less than half or greater than twice, then it's going to ask you to try again. If everything goes well and the user enters an acceptable length for both horizontal and vertical segments, then the program prints out the following message. It says enter a positive integer. Now the user can enter any positive integer. There is no limitation on how many digits the integer can have. It can have as many as you want. And that's the beauty of it. I'll tell you basically, how to handle this when you're writing the C code. After the user enters that, then the program checks to see if the user's input is a valid positive integer. If not, it's going to ask you to try again. But otherwise, the program is going to print out the 7-segment representation of the number using all those asterisks that I mentioned. So in this example, I only have 1 digit 8, but if, for example, the user input is 88, you need to print 2 of these side by side. So just have this same thing, same representation of 8 next to it, right? And then there would be a small space between the 2 numbers. The amount of a space would be only 2 columns of spaces between any 2 adjacent digits of a number. So if you have 88, you have 8, just like this, followed by 2 columns of white spaces, followed by another 8, right? If it's 888, we're going to just keep doing this again and again, just keep place 3 8s together with, some spaces in between each 2, and that's it, right? Each 2 neighbors. All right. So after, the program prints the 7-segment representation of the number, then it repeats the same process. Again, asks for a new positive integer. It says enter a positive integer, and after the user enters that, it's going to print the 7-segment representation. To end this infinite loop, the user can simply press Control and D. Control and D are basically the two the 2 buttons that when the 2 keys that when the user presses, it passes an end of file character to the program through its standard input stream, and basically that should end your program. Right? So in order to submit this code or this assignment, you need to submit a single zip file. There is no other extensions acceptable on Canvas. And you need to compress the following files in the zip file. First of all, if you have one source file or C source file or more than one C source file, you need to include all of them. You also need to include, let me open the latest version of this. I changed this a little bit. Give me a second. I already have it somewhere. This is the latest version. Yes, so this is what you need to submit. You need to submit all the C files related to your assignment. So normally you have only one or two C files. You don't need to have too many C files. You can put your whole program in one C file. Later you will see, as the assignments get harder and harder, you may need to have like multiple C files. But in this example, this is a very simple program, so you can have everything in one C file. And you may have some header files. Again, for this programming assignment, your program may only have a C file, and you may not have any H files. That's totally fine. And also, you need to take a snapshot of your Unix terminal when you're running GDB on your code. GDB is a debugger in Unix. I'll show you at the end of this video how to basically take that snapshot and how to basically run GDB on your program. And finally, a Makefile. So these are the four items that you may include in your submission. Your submission should be zipped, should be a zip file, compressing all of these, right? As I said, you may not have header file, or you may not, you may only have one C file. That's fine, but you must include a snapshot of your Unix terminal running GDB, and also the Makefile, right? When you're creating the Makefile, by the way, for those of you who don't know what Makefile is, I already posted a video on Canvas. You can watch the video explaining in detail how Makefile allows you to create an organized way for users to compile a C program, build the C program, and make the executable for the C program. But after you watch that, you know what Makefile is. You need to use 7seg as the name of the executable for your program in the Makefile to make sure that the Autograder can successfully run your program. And at the end of this video, I will show you how to run Autograder as well. So I will show you how the GDB works and how Autograder works. There is a video on Canvas for the GDB as well, but I'm going to briefly tell you what to do for GDB. The snapshot that you need to include in your submission. And here is the grading criteria. The Makefile is 15%. The correctness of your C syntax is 10%, including the GDB. This one includes the GDB snapshot as well. So the 10% is for both correctness of C syntax and having the GDB snapshot. Then you have the proper scan and error checking of user input via keyboard. That's 15%. That's another criteria. And finally, for properly printing digits on the screen, you get 60 points. The total would be 100 points. And basically, to check the last two, we use the Autograder that I posted on Canvas and the four test cases that you see in it. I will explain the Autograder at the end of this video. So what I want to do next is to show you how this starter code works. I have given you a few lines of a starter code just to start things off and make sure that you know how to begin. I have posted a zip file called starter code PA1 on Canvas. If you unzip it, you're gonna see this folder, and inside that you have a single Makefile. You may not change the Makefile if you don't want to add any other C or H files to this. So you can, this Makefile can be used without any change if you don't want to add any other file. And I have a C file, 7sec.c. I'm going to open both of them. Let's open the Makefile. First of all, don't change the name of the Makefile. Name of Makefile should be the same as what you see here, or maybe the Makefile with capital M, but nothing else. There will be no extension to the Makefile, so don't submit Makefile.txt. Otherwise, you don't get the credit for the Makefile. As you noticed, I have put about 15 points for the Makefile in the grading criteria. That's on purpose. You're gonna lose 15 points if your Makefile has an extension of txt. The reason I do this is because I want to make sure that you all know how to add Makefile, and if you don't add the Makefile in the correct way, then the grading process of your program would be a lot longer because we cannot use Autograder on it. So take it seriously. For the first assignment, I've already given you the Makefile, but for the following assignments, you need to create your own. And this is like a good template for every other assignment. It's not a big deal to change this for the next assignments. The way the Makefile looks like is basically it specifies some constants or macros. About that. Like, for example, CC means GCC, that's the compiler. For C code, I have a bunch of flags. This means all the header files are in the current directory. -G means let's ask GCC to keep all the tables and information about variables and functions so that we can run GDB after this. You need to include -G when you want to debug your code with GDB after compiling. -W ignores all the warnings. And then here is the macro with dependencies. It's empty, but you may want to add any header file names here. For example, if you have a header file named 7sec.h, you can place it here. Otherwise, don't worry about it. Leave it empty. And here is the object files that will be generated after compiling the C files. Here I have 7sec.o. If you have like more C files, then you're going to have more O files. Then you just place them right next to it, separate them by space. I will explain Makefiles in another video. You can watch the video for next for the details of the Makefile. Here is the commands that I have for compiling C files and creating the corresponding O file or object file. And then finally, this is the command that I have for generating the executable. The name of the executable is 7sec. And that's exactly what the assignment wants you to do. Actually, I have highlighted it. I have bold, made the the statement bold so that it's super important to keep the executable name 7sec, because the Autograder that is going to be used to grade your assignment automatically will use this word for your for naming your program's executable, and that's it. So let me save this. Let's move forward to the next item. I have in the same starter code, I have a C file. Let me show you the C file. This is basically 5% of the assignment. You need to do the other 95%. But it's a good start because it basically show you how to start your program. It says it prints out, this is a 7-segment display, press enter after providing any number in the keyboard. So it basically sets out some rules for the user when the user wants to interact with the program. Then it's going to declare some temporary variables, like, or I should say, local variables like like segment width. That's the length of horizontal segments. We have a flag that I'll set when some error happens to the input. We have a placeholder for users input. So when user enters anything, this string is supposed to hold it. Strings in C are represented by an array of characters. This is an array of max len plus 1 characters. Max len is set to 100, assuming that the user is not going to enter more than 100 characters in each line as a command or as a input to this program, and that's a reasonable assumption. The define will basically define a constant that's taken care of by the preprocessor, the entity that kicks in before compiler compiles your program. And then this is basically an include statements, including the library stdio.h, which contains useful declarations for different functions like printf that you want to use to print messages on the console. Then I have some initialization. Then I have a while loop. This is an infinite while loop. Then I'll say, please enter the length of the horizontal segment. The reason I have this print in the while loop is because if the length is not acceptable, we're going to ask the user to try again. Then I have an input error flag and segment with value set initialized to 0. Then I have a for loop that goes over every letter that the user may enter in this line. The maximum is always max len, but in this case, if I is 3, that means the input is not acceptable, because for the length of horizontal segments, the user can only enter a number from 3 to 40, which is a 2-digit, 1 or 2-digit positive integer. So if I is 3, I'm going to set the flag of input error to 1, and I'm going to break out of the for loop. Also, if that's not the case, I will get the next character and I will check the character with new line. If the next character is new line, that means that's the end of the user's input for this command. I should say end of user's input, not input error, sorry. And then I need to set the string I to 0, because that's when that's where the string ends, because the string has to represent a string that represents the user input. So you need to end that string with 0. 0 is a special character that specifies the end of a string, right? So that's why I set the string I to 0 and I break from this loop. Otherwise, if it's not new line, then I will check string I with 0 and 9 to see if it's a digit. If it's not a digit, that means either the ASCII code of ith character is less than ASCII code of digit 0 or is greater than the ASCII code of digit 9. Then set an error flag equal to 1, and then break out of the loop, because non-digit characters are not acceptable in this point. Otherwise, if no error happens, that means you have a digit for the next character that you have received using getchar. So what you need to do is to treat that character as a digit, converts the ASCII code to its numerical value by doing this. Subtract 0 from string I, that's going to give you the ASCII, the numerical value of the digit that you have just received from input, and then add this by segment width, the current width, times 10. This is accounts for previous digits that have been previously entered in the previous iteration of this for loop. So this formula basically assembles the segments width as an integer,
and converts the number entered by user to an integer. That's how it works. It looks a little bit difficult to understand, but it does nothing but converting the number entered by user to an integer. And that's it. That's the end of the for loop. After the for loop ends, we check whether there's an input error. If that's the case, we're gonna get rid of every single character that the user has entered up to the new line by just doing this while loop. And as you see, the while loop has no body. After that, right after the while loop, I have a semicolon that gets rid of all the remaining users' input. And after that, I will say if the segment width, which is the number entered by user, is less than 3 or greater than 40, or the input error flag is raised, print that the given value is not acceptable, and then we're gonna continue this while loop again. We're gonna ask for user to try again. Otherwise, if none of these happen, that means everything is in good shape. The segment width is between 3 and 40, and there's no error. So we're gonna break out of this outer while loop, and that would be the first step of the program. Then after that, you need to ask for the vertical segment in a similar fashion. Then you need to ask loop for a new integer, and then after the user enters the integer, you need to print it out using the 7-segment representation. I haven't continued after this. This is the end of the starter code. I have just created some while loop that gets rid of every single other character that the user enters, and at the end prints in. So you need to replace this by all the meaningful code that you need to have to represent numbers with 7-segment representation. Let me show you one more thing. The next thing I wanted to show you here is the Autograder. So on Canvas, I have the zip file, the PDF file that shows you the assignment specification. We went through it. It shows you this. It gives you this zip file that's called PA1 AG. AG stands for Autograder. I'm gonna show you the detail of that. And then the starter code is what I just showed you, the C file and the Makefile. So you need to complete the starter code, and then you need to use the Autograder to test your code and make sure it's working properly. Here is the unzipped version of the Autograder. Let's open it. This is what you see in it. You have an H file, you have a C file, you have a TXT file, you have a Makefile, you have a PL file, you have a README ML file. It's a complicated document or folder, if you want to call it. You don't need to understand every single detail of the Autograder. If you want to know more about it, just open README and read through this. Actually, it's better to open a bit better editor. It's a notepad. It has given you all the details about the Autograder, but you may not be interested in reading all of that. So I will briefly tell you what this Autograder does. First of all, this is how you see your Autograder when you download it, right? You have all of these files in it, right? In order to use it, you need to first make a zip file, just like the way you want to submit your assignment on Canvas. You need to zip your files together into one file, call it a zip file, and you need to place your zip file in this folder so that the Autograder can test your code and see how it works. Without looking at the Autograder's details, I'm gonna just do that. I'm gonna go to the folder that I have. I'm just gonna test the starter code. I don't want to test anything else. I'm just gonna move this zip file. This is, of course, an incomplete submission, but let's say this is your submission. And I'm just gonna copy this file and move it into your Autograder, which is here. let's place it here. And now I'm gonna run the Autograder on this submission, which is an incomplete file, right? So this is how I do it. I will first navigate through the folder that I have my Autograder in. So if I list all the files in this current directory, I see the pa1-ag folder. I go to that. This is my current directory now. List all the files. I see a bunch of stuff. I need to first make the Autograders executable, because Autograder is another C program, right? It's not your program, but it's a program that is given to you. So in order to build the executable for the Autograder, you need to make it. This Makefile is the Makefile for the Autograder. It's completely different from the Makefile that I showed you earlier for your program. By the way, this part of showing you the Autograder is just for those of you who want to check your program to see if it's correct 100%. You don't need to do this, right? But I will strongly suggest that you test your program with the Autograder before submitting it, so this way you know what grade you will get. So what I will do is just make, using the Makefile, make basically is a command that runs the Makefile, and basically in this case it's gonna build an executable for the Autograder. When I press enter, as you see, it runs these two commands and it will create an Autograder executable called AG. Then I will say /AG and the name of, you don't need to pass anything else if you want to just run the Autograder in default mode, but I always use -XS for testing only one file. -XS is a command, is a flag for Autograder that basically how can I say it? It basically skips the MOS step. MOS is a PL pair program, as you see here. It checks for the similarity of multiple codes. So this is only for the grader purpose. The grader uses this to check the similarity of your code against others for checking the academic integrity. But when you want to run it on one submission, you don't need to run MOS, because that's going to add a lot of headache or overhead on your your Autograder experience. So just say ./AG and add a -XS here, and it's gonna automatically unzip any zip file that is in this current directory. In this case, we only have one, and it's gonna basically, after unzipping it, it's gonna remove all the O files, and then it's gonna make your executable. Then it's going to run your program multiple times on multiple test cases. It's a longer story. After I run it, you will see. It didn't take the Autograder much to finish running all the test cases on your program. This is not your program, it's like the starter code. And that's it. When I finish, I list all the files, I will see a result.txt report. I can open it. I can just say cat results.txt, and I can see the output. This is the output of your Autograder. I'm going to open it in a different way. This is not looking so great, so I'm going to just open it with a Notepad++. Here it is. As you see, it shows that the Autograder has ran your code once on the first test case. The first test case input is this. What does it mean? It means that the inputs first, the user first enters 2 and then 3. 2 is an invalid number for the horizontal length. So that's why you will see this message. It says, please, it says the given value is not acceptable. And then after that, the user enters 3. That's an acceptable one. And then after that, you will see the starter code just prints and it ignores everything else because this is an incomplete submission. But if your program works properly, it will print the expected results, which I'll show you later. Let me show you right now. So this is the results of running the Autograder on the incomplete code. But if your code is completed, then you will see this. First of all, for this input, for this starter code, for this test case, the inputs are 2, 3, 41, 12, 4, and 8. 2 and 3 are both entered for the horizontal segment's length. 2 is invalid, 3 is valid. So that's why you see the given value is not acceptable for 2. For 3, it's valid. So the program moves on and says now enter the length of the vertical segment. When the user enters 41, then it prints it's not acceptable because the number should be between 3 and 40. After the user enters 12, it again prints the value is not acceptable because 12 is more than twice the length of horizontal segment. And then after the user enters 4, then the program will be happy and says enter a positive integer. And then when the user enters 8, the program's output would be here, right? This is the number 8 using 7 segment. And as you see, this is the output. std out means output, std in means input, and CLA is basically the command and arguments. For this program, we don't have any command and arguments, but eventually for the future assignments, we will have command and arguments. And that's it. For the next test case, we have another scenario, 10, 12, 23. This is the user's input for the horizontal, and this is the user's input for the vertical segment's length, 10 and 12, and then 23 is the number that you want to print. And this is the number 23. Let me zoom out so you can see the 23. This is 23. That's the expected output. The next one is 5, 3, 456, and 79. So after the length of horizontal and vertical segments are set to 5 and 3, then the user enters 456. This is 456 in 7 segments. You can check out, the visual of it. This is like 456. And remember, because of this 5, we have 5 asterisks for the horizontal segments. And because of this 3, we have 3 rows of asterisks for every vertical segment. And then the next one would be 79, and this is 79. This is 79, right? If you want to know it. This is 7, and this is 9. The last one is the hardest one. It says set the horizontal length to 8, vertical to 5, and then the number is this 24-digit integer. This is the output. As you see, I have 24 characters. This is 10. This is 1. Sorry. This is 10, 10, 10, all the way to here, and that's pretty much it, right? So your program should print this. That's the expected output. But if you just run the starter code or run your Autograder on the starter code, then it doesn't show you anything just because the program is incomplete. So the goal is to make your program in a way that when the Autograder is executed on your program, it prints this output. The next thing you need to know, so I just showed you how to run the Autograder. Just zip your files into a zip file, just like when you want to submit your submission. Put the zip file in your in the Autograder and then run the Autograder. Do not submit the Autograder along your submission. If you do that, you're going to get a lot of points off because the autograder cannot run your program because you're not supposed to include the autograder inside your submission. In your submission, you have 4 items to include. 1 is all the C files, 2, all the H files you may have, 3, the snapshot for the GDB, which I'm going to talk about right now, and 4, the what was the 4th one? The Makefile. The Makefile is super important. All right. Finally, I need to talk about the GDB, which is a debugger, right? You can watch a video that I posted on Canvas about that, but I'm going to just show you how to run the debugger on your, let's say, a starter code, right? So the first thing I need to do is to navigate through my to the folder that has my code. Let's say we are navigate to the folder with starter code in it. And then, as you see, I have a 7-segment.c and a Makefile. First of all, I will use Make to compile my C file and make the executable. Right? After I do this, if I list all the files, I will see an executable here, 7seg, and this is the executable. I can run it without the autograder, without the GDB, and basically ask me to enter a number. If I say 1, it says invalid. If I say 100, it says invalid. If I say hello, it says invalid. If I say 23, let's say, it would be valid, and that would be it, right? That's it. So that's basically, and at the end, I just press Control D to just end the program. That's when you run your program without the debugger. But if something is wrong and you don't know why, and you want to use debugger to just go over your code line by line, just like when you use an IDE for a Java program and use a debugger of it. For C programs in Unix, we just have GDB, which is a not so fancy debugger with a user interface that is not graphical. It doesn't look good, but it's an autograder. It's a debugger that you can use. For using GDB, you need to have the executable first. I already have the executable because I have made my executable using make command. Then I will do GDB. That's the command, and then I will basically place the name of the executable here, which is /7seg, and that's when you begin running the GDB. It basically tells you welcome to GDB and do whatever you want to do. Here I will do layout next. Just see the layout of the program. No sources available yet because I need to put a break first, a breakpoint on some point. I can either put a number that shows the line number, or I can put the name of a function like main. This is going to add a breakpoint at the beginning of the main. That's the most logical point for the breakpoint. And then I will say run. When I say run, it shows me the code. Right? This is the starter code. And I can just say N or next to go to the next line. I can do refresh. If I see my the code doesn't look fine, then I can say, let's say, for example, next, N or next both go to the next line. If I say refresh again, it's going to refresh things. Then I can say, for example, a step into a function. I can let's say watch for a variable like I to see how it will change. Then I can say next, as you see, because I was watched, now it says the old value was this, new value is this. Sorry. And I can just go forward. When I say take a snapshot of GDB, I mean this. You know, when you logged in with your own username on Ocelot, you can run GDB the way I did and just take a snapshot of it right now and just include that snapshot as an evidence that you have ran your ran the GDB on your program, so I can see that you have tried at least once how GDB works, right? And when you want to quit, just press Q and that's going to quit. It says, do you want to quit? I will say yes, it's going to quit. All right, so that's pretty much it. Hope you can finish the assignment. You need to write a good amount of code, but it's not difficult. You already know what to do. You just need to create 7-segment display for integers. Thank you.